Hi, I'm Jane Kay. I'm a Senior Scientist at Dairy NZ, and this is a Feed Right video on lipid metabolism. In this video, we will talk about the different types of lipids that are found in feeds, what happens when a cow eats these lipids, and how the different lipids affect cow production and performance. So, what is a lipid? A lipid, or a fat, as it's more commonly called, is a substance found in plant and animal products that is not soluble in water. The basic structure of a fat is a carbon or glycerol backbone with 3 fatty acids connected to it. The fatty acids can vary in length and in the number and position of double bonds that they have. If they have no double bonds, they are known as saturated fatty acids. If they have one or more double bonds, they are called unsaturated fatty acids. The number and position of these double bonds alters the way the fatty acids are digested and can also alter their biological activity. On a weight basis, fat contains more than twice the energy content of carbohydrates. However, only a small amount, no more than about 6%, can be included in the cow's diet. This is because too much fat in the diet can negatively affect rumen function, reduces dry matter intake and cow performance. So let's look at what happens inside the cow. When a cow eats a diet containing fat, the fat is rapidly hydrolyzed in the rumen. This means the bonds between the glycerol backbone and the fatty acids are broken. The sugar units in the glycerol backbone are used by the rumen microbes as an energy source, while the fatty acids are released into the rumen. As mentioned before, these fatty acids can be different lengths and they can be either saturated or unsaturated. Now this is important as it determines how they are processed in the rumen. We'll start with the unsaturated fatty acids, as these are the predominant fatty acids found in forages and grains. Unsaturated fatty acids, so that's the fatty acids that contain the double bonds, are actually toxic to many rumen microbes, particularly those that are involved in fibre digestion. In an attempt to detoxify these fatty acids, they undergo a process in the rumen called biohydrogenation. Now, biohydrogenation is simply the addition of hydrogen ions to the unsaturated fatty acids. The hydrogen ions replace the double bonds, so the fatty acids become more saturated, and in doing so are less toxic to the rumen microbes. Now, due to this biohydrogenation process, the profile of fatty acids that leave the rumen is very different from what was in the diet. Although the majority of unsaturated fatty acids that are eaten are completely saturated before they leave the rumen, some fatty acids escape during the biohydrogenation process. This depends on the chemical structure of the fatty acid in the diet and the rumen environment. The different fatty acids that are produced during the biohydrogenation process can have very different biological effects depending on the number and the position of the double bonds remaining. Now generally, a cow's diet contains about 3 to 4% fat, and the biohydrogenation process is able to detoxify the unsaturated fatty acids. However, if the cow's diet contains too much fat, the biohydrogenation process is overwhelmed. The fatty acids cannot be saturated and rumen function is reduced. This results in reduced fibre digestion, decreased dry matter intake, and ultimately reduced cow performance. If we look at the other types of fats that can be found in the cow's diet, we have the saturated fatty acids. These are generally found in animal fats and also in some byproducts such as palm kernel. Because these fatty acids are already saturated in that they have no double bonds, they are not as toxic to the rumen microbes. This means they do not have to undergo rumen biohydrogenation and can pass through the rumen unaltered. Now, the other type of fat that can be included in the cow's diet is protected fats. Protected fats form the basis of commercial products such as megalac or hyprofat and consist of fatty acids that have been chemically treated. The chemical treatment helps reduce the interaction between the fatty acids and the microbes, and therefore reduces the negative effect that fat can have on rumen function. This means some additional protected fat can be added to the cow's diet without negative consequences. However, we are only talking 1 to 2% additional fat in the diet, and careful monitoring is still required, as even protected fat can reduce dry matter intake and negatively affect performance. The other use of protected fats is that they can be used to deliver specific fatty acids to the cow to elicit a particular response. Unsaturated fatty acids, such as CLA, can be used to reduce milk fat production. However, in the unprotected form, these fatty acids would be biohydrogenated in the rumen and would lose their biological activity. If they are protected, they pass through the rumen unaltered and thus are made available to the cow. So let's look at what happens to the fatty acids once they leave the rumen. From the rumen, the fatty acids pass through into the small intestine, which is the primary site for fatty acid absorption. In the intestinal cells, they are reconnected to a glycerol backbone and packaged into little parcels known as triglyceride-rich lipoproteins. These lipoproteins enter into the lymph vessels and then into the general circulation. Once in the general circulation, they are directed to different parts of the body depending on the status of the dairy cow. In a lactating cow, lipoproteins are directed to the mammary gland, where they are broken down once again into fatty acids and glycerol and used to produce milk fat. If a cow is in a positive energy balance, lipoproteins are also partitioned towards adipose tissue and used to store fat or gain body condition. So that's what happens to fat that is in the cow's diet. However, the diet is not the only source of fatty acids that are used by the cow. If the cow is in a negative energy balance, fatty acids that have been stored in adipose tissue are released into the circulation. Now, this is known as mobilizing body fat or losing body condition. The fats that are released into the circulation are termed non-esterified fatty acids or NEFAs, and blood NEFA content is often used as an indicator of the energy status of the cow. The higher the blood NEFA content, the more negative the energy status of the cow. From the adipose tissue, these fatty acids are transported to the liver, where they undergo a process known as beta oxidation. This generates energy from the fat that the cow can use. Now, if the cow is in severe negative energy balance, for example, during an acute feed deficit or an early lactation, in particular in cows above target body condition score, when they are mobilizing large amounts of body tissue, there are a lot of fatty acids transported to the liver. These cannot all be converted to energy, and fat can begin to build up in the liver. The dairy cow is not efficient at exporting excess fat out of the liver, and the deposit of fat accumulates. This can cause reduced liver function, it predisposes the cow to metabolic diseases, and reduces cow production and performance. So in summary, the dairy cow can use fatty acids from the diet to synthesize milk fat or to store as adipose tissue for later use. If she is in a negative energy balance, she can mobilize her own body stores and use this body fat to generate energy in the liver. In the dairy cow's diet, the fatty acids can be unsaturated, saturated, or protected. The majority of fatty acids in forages and grains are unsaturated, meaning they contain at least one double bond. These fatty acids are toxic to rumen microbes, particularly those that digest fibre, and consequently they undergo biohydrogenation in the rumen. A small proportion of dietary fats are saturated, which means they contain no double bonds and are therefore less toxic to the rumen microbes. And finally, protected fatty acids are chemically treated so they don't interact with the rumen microbes and pass through the rumen unaltered. Generally, the level of fat in the diet is 3 to 4% of dry matter, and recommendations are no more than 2 to 3% of supplementary fats are added to the diet. This is to reduce the risk of detrimental effects on rumen function, intake, and performance of too much fat. So, by the end of this video, you should be able to name the different types of fats that are found in feeds, know what happens when a cow eats these fats, and understand how the different fats affect cow production and performance.